So thank you very much. I'm excited to be here to join and to have the option to present to you a little bit about our offering. We have enough time. I'll start with a few slides just to align you and how CyberMDX fits into the overall Forescout offering. And then we'll go through the system itself, show a little bit how it works, what can be done with it, and how it helps our customers to improve the security of their healthcare organizations. You are more than welcome to ask questions during the presentation, during the demo itself. Let's make it interactive so I will be able to better focus on what's interesting for you and not just show everything from my side, but maybe you wanted to focus on something else. So please feel free to ask questions to whatever is needed, and we'll go from there. So let me just share my screen. Can you see the presentation?
Yes.
Great. So as Andrew said, the Forescout has acquired CyberMDX to complete the offering in the healthcare environment, where we are focusing mainly on IoT and medical devices. We're a security leader with a lot of customers that are covering specifically this part to make sure we are providing them the best protection and information available. We'll talk a little bit about the alignment with the Forescout security framework and how CyberMDX fits into it, what we actually do, and then I'll show you why healthcare providers choose us. So first of all, when we are looking at the threat landscape, organizations are building security frameworks, align the policies, the technologies, the risk management, and then let's say life happens. So things are moving, are changing. We are having acquisitions. We have additional people joining the company. We have new tools being introduced, new medical devices, and there becomes a gap between the framework that was initially built and the real life scenario. So the goal here is to align together with the Forescout Continuum to align the security framework with the actual digital terrain to continue to operate it continuously and maintain this alignment along the time. So how CyberMDX comes into play? When we are looking at the hospital network, it's in many cases a much more complicated environment than regular networks, because we can have 10-year-old, 20-year-old medical devices still on the network, connected through serial ports to some other devices and switches, and only then going to the network, and things are still being in use. And we can have like the newest and latest CT machines, MRIs. We can have devices running proprietary operating system. So it becomes quite a mess to be able to, first of all, understand, and moreover, to actually control, to apply controls on this complicated network to make sure that on one hand will be secure, and on the other hand, that those outdated medical devices continue to function, that the newest medical devices continue to function, and of course, we don't introduce any patient risk during this process. So our approach to this is separated into 4 parts. First one is building the inventory. This is an extremely important part. We need to properly understand what we have in the network, how it behaves, what it does, the identification of those unique and special medical devices. Once it is done, we can build the risk assessment and decide on the preventative actions. On how do we improve the security posture without compromising the ability to operate those medical devices. Then we can apply the compliance and governance processes that we have inside the organization to make sure that our risk assessment and actions are aligned with the policies. And of course, have the detection and response. So if something new happens, to make sure that we are able to identify this and that we can build the proper response mechanism to make sure, for example, if we detect right now, I'll show this in the environment demo. So if we'll detect right now, let's say, a city communicating to somewhere in Russia, what do we do with this? Or if we have anesthesia machine doing this. So on one hand, we want to make sure that the device will continue to function. On the other hand, we want to make sure that it will stop communicating with Russia. So we are building those things together with our customers to make sure that those things will continue to work, but we are mitigating the risk. So the idea is to have the full discovery and assessment with the context and apply what CyberMDX defines as a device-centric risk management. I'll show you how it looks exactly in the system. Again, governance, and of course, automation and the response of the security workflows via integrations, via sharing the insights, and accelerate the response. So this is the presentation part. Any questions before we go into the demo itself? Okay, just share the demo environment. And again, please feel free to ask any questions, raise hand. Something in the chat. No, okay. Let me know if you can see the demo environment.
Yes, definitely.
Great.
Probably here we have we will have some questions, definitely.
Awesome. Feel free. So again, this is a demo environment. It's not perfect. Production systems look much cooler, but unfortunately, I cannot show them to you. So we have here basically two main parts. On the dashboard, on the left side, we have the inventory information about the different assets that were detected by type. And on the right side, we have the more security-oriented information. Assets with highest risk by vendor or by type, threats that were detected over time, information about vulnerability. And we can add, I'll show you here, some specific trends and monitor specific things that are interesting for us. We can add them also to our dashboard. So on the left side, we have the navigation pane where we have, let's start with assets. So this is basically the list of all the assets that the system has detected in its organization. We can have different views. We can have a security-oriented view, which shows us columns more related to security personnel, like available actions, action in progress, mitigations, more network-oriented context, which will show us the VLANs, the subnet, the connection type, protocols that are being in use, and the biomed-oriented view, which will give us information about the equipment function, vendor access, serial number of the device, application version, studies that are being done, MDS2, etc. All those things can be modified. So if I'm a biomed personnel and I want to add the VLAN information for some reason to my view, I can have it here. I can sort it, can move it. I can filter and say, show me only VLAN 20. So all of this is a very flexible way to actually build the views that you're interested in. Let's dive a little bit deeper. Let's take this highest risk Siemens CT machine and see what we can see, learn, and do about it. So on the left side, we see the detailed information about the machine itself, all the information that was detected, like the models, the vendor, the type, its location, MAC address, serial number, the device criticality when it was first and last seen, when we had the last vendor access to this machine. And here on the right side, we have the risk assessment. We have the take action part. Then we have a network, organizational, and software information about the device. We'll focus on this part, on the risk assessment and the take action at the moment. So we have for this device a risk score of 94, which is critical. The risk score is calculated based on the asset criticality. So how critical is the device for the organization? There are predefined values and can be modified by, of course, by our customers. And so this is one part, and the second part is the actual risk that is detected on this device. So since we have here 4 critical vulnerabilities, a threat, and 3 compliance issues, the cube is the top right corner between 89 and 100, and this is the device risk. Now, so this is the risk. We can, of course, dive deeper. We can see the actual vulnerabilities that we have. And there are 3 RDP vulnerabilities and 1 DHCP vulnerability. They are related to the fact that this is an outdated operating system. Nonetheless, they are here. So what we can do with this? CyberMDX provides recommendations on 3 layers: device level, network level, and perimeter level. Right now, we're looking at all of them. If you look at the device level, we'll see that there is an SMBv1 in use, and there's a recommendation to change this. There is an outdated software running on this machine, and it also has an outdated OS. But of course, we understand that you cannot really just go and upgrade the CT operating system, and we actually need to have some easier tools available for our customers to mitigate those threats. And this is where the network level mitigations come into play. We have here 2 types of actions, a block list and an allow list. If you look at the block list, it basically says, let's block specific types of traffic to this device on the network level. So if we go and block the RDP protocol, we will mitigate 3 critical RDP vulnerabilities. We can actually view this access control list that will be applied. We can copy it and we can go and apply it wherever we want. But what if someone still needs, let's say security personnel still needs access via RDP to this device, or the force vulnerabilities that we have is related to the DHCP? So in this case, we can go to allow list and let's say allow by IP. So we can say we want to allow the RDP access, but only from our security team subnet or segment or their specific IP addresses. And we also want to allow the city to receive DHCP, but only from our enterprise DHCP server. In this case, applying allow by IP will actually mitigate all the 4 critical vulnerabilities that we have. Sorry. Maybe I changed it a little bit. So this will actually mitigate the vulnerabilities that we have and will reduce the risk score of the asset itself. We still have risk here because it still has a threat and there's 3 compliance issues. It has a recall, it has an outdated version, but the risk itself, we no longer have the 4 critical vulnerabilities that we had before. We can go deeper. We can see the information about the network communication of this device. We can see, for example, here, communication with a malicious website. Is an indicator that this device could be compromised with a WannaCry cryptoware. And we have here the information about the communication attempts. This is actually a DNS request for a kill switch. We can see information about the device analytics, more biomed-oriented view. Cyber risk, we've seen this, vulnerabilities. We have also compliance issues. So we can see that all the vulnerabilities were mitigated. We can view, of course, including the resolved as well. We can see compliance issues related to this device, and we can see recall information on this specific asset. Any questions so far? Okay, let me know if you get any. So we've seen that we have here 2,600 assets. We took a look at one of them and we, let's say, took care of it. But we still have 2,615 assets. The idea that we can do specific action on each single device, it is really cool. But when we really want to work with the system, there is a much better way to do this. So let me show you the cyber risks page. If you look at vulnerabilities, so we took care of 4 of them right now. we still have 23,000 vulnerabilities total in this environment. It might be quite a challenge to actually understand, where do I start? What do I do with all of them? This is too much. And CyberMDX has introduced something we call group by case, where we actually identify, let's say, group of devices. Let's take this one, for example. We have 208 Baxter infusion pumps, and all of them are vulnerable to Ripple 20 vulnerability. Ripple 20 is a bundle of 5 vulnerabilities. So basically, this one line represents 1,040 different vulnerabilities. So this helps us to prioritize, and the system builds a risk score based on the device criticality. So in this case, we have a GCT with a critical vulnerability. This is why this is the highest risk at the moment. And then we have high vulnerabilities based on either the device criticality, the risk itself. We have information here, of course, about the CVSS score of the risk. We can see the asset categories, the device criticality, and the number of devices. So combining all of those, CyberMDX provides its customers with an actual list to understand where should they start with the, let's say, handling the vulnerabilities in the organization. Same is true with compliance issues. So if we are looking at compliance issues, these things can be like default credentials, end-of-life operating systems, assets on guest network, usage of deprecated protocols. All those things are as well sorted by cases. Now let's take a look. We have here 18 GE ECG machines that have default credentials. I can tell you more than that. The fact that CyberMDX was able to see that those are default credentials means that they are being sent in clear text over the network. So this issue is, let's say, much worse than it might seem first. Okay, so we have this case. We can see all the 18 affected assets here. We can do things with this. So we can assign, let's say, this whole case, we can assign it to someone to make sure that they will handle this case. We can add nodes. We can create tickets. So integration, for example, with ServiceNow. And then this will be managed within the ServiceNow ticketing system at the customer. We can resolve it here. So we can say, for this specific asset, I have changed its credentials. So resolved, resolution, reason will be remediated, credentials changed, resolve. So this way, the system allows you to work with those risks, threats, compliance issues, to handle them, to have all of the information about them. And we can also see by category, so we can see the how many risks are on different device types and the types of risks that we have here. This same idea is also behind our Biomed Insights. So when a Biomed personnel needs to work with the system, they have recall cases. And we have here, for example, a recall on BD infusion pumps, some issue with keypad lifting and fluid escaping. So, and it affects 101 devices. Same idea is here. We can assign it to someone, we can open a ticket, we can resolve it. And we also have some nice insights about the imaging analytics. Let's say the imaging device utilization, cross-site load. If there are multiple sites, we can see the load in the different sites. It might help also to properly navigate maybe patients. If we have 2 MRIs and one is very busy and the other one is not, we can have this here to help us understand the actual utilization of the devices. Questions so far before I go to Control Center? Okay. So Control Center, this is a really cool place. Remember I told you that we want to know if there is any device communicating to Russia? Well, let's build this rule. So medical devices communicating to Russia. Cool. So I select which type of asset or any other information about the assets that we have. So I'll choose category and call it medical device. And the additional filter I want to add will be communicating with external entities, country. Let's take Russia. And we can, of course, can add multiple countries, so Russia and Belarus. And let's say any protocol. I can choose specific ones, but let's say I want to know about any medical device that will communicate with Russia or Belarus. What do I want to do with it? So we can do different things. We can add tag, and the tag can actually trigger an action within Forescout, within the rest of the modules and capabilities that we have. So for example, I isolating this device from external communication, making sure that it will not have any internet access and limiting its internal access, but still allowing these medical device to actually function. And we can add another action that will be, for example, send an email alert. So if the result is above 0, please send an email to Valerie@hospital.com. We choose a header and the footer, and this will actually send the information about the devices that have matched these filters that I have created. Now, once it's done, I can actually add those to here. Let's say plain text PHI to external entities. And we'll have this information presented to us, and we can, of course, once logged in, we can view matched assets, and it will show us a filter just of the assets that are matching the specific rules that I have created. It's very flexible, allows us to do a lot of different things. We have a question of how is Russia defined? So yes, this is based on GeoIP, IPv4. That's correct. There might be some additional logic I might not be familiar with, but if this is important, we can check it. The last part I want to show you, well, almost last one, I just want to give you some insight of the different integrations that CyberMDX currently supports. And of course, we are being, let's say, ingested as a part of the whole Forescout offering and as a module of Forescout, with also related integrations that Forescout supports, which is much more. So basically, this will be greatly enriched quite soon. And the last part I would like to show you is actually the reports. So we have two pages in the reports here. The first one is the executive reports, and we also have the advanced reports section. So executive reports, just as it says, it provides a high-level overview. In this case, the security posture. We can see the devices with a high risk score and the number of assets. We can see network hygiene information based on the different subnets and how they are composed from different device types. You can see information about the detected and resolved risks. And the really nice one is called Industry Benchmark, which actually allows each healthcare organization to compare it to all our other customers and to see where they stand in three main parameters. The first one is patient safety risk. Basically, it's the risk level of the devices directly involved in patient safety. The care delivery risk, the ability of the hospital to deliver patient care, and the data confidentiality risk, the risk level of devices that have seen communicating, sending, or receiving ePHI. And this gives, again, a very nice high-level understanding of where you stand, and of course gives the information about the top contributing assets to the risk score. So if the risk score is not so good, these are the assets you want to focus on, of course, in the cybersecurity page to improve your relative position to the industry. In the advanced reports, we have a more in-depth information, let's say list and detailed information about the new assets, information about recalls by vendors. We can filter this or by different assets, information about forbidden communication. So we can define in the system specific countries that any communication to them is forbidden, and will trigger an alert. So at the moment, just IRAN is defined here. Information about outdated software. So we can see both the type of the device and the current software seen here and the software version we have seen, let's say, in the wild. So we can filter by just IoT, the medical devices, or servers, and see the information just related to that type of devices. So we have here ultrasounds, X-rays, Alaris PC units, etc. And the last really nice one is unsupported Windows operating system. Again, we can filter and say, show me just the medical devices with unsupported operating systems or user endpoints that we'd probably like to handle them. Questions. Okay, we have another question here. Is it possible to add device location tag, for example, to see the particular device at risk is located in building, office, etc.? Great question. So there are different ways to do it. First of all, you can add a tag. Like here, if I look at an asset, take a look at a specific asset, I can edit tags. I can add tags, can create a new one. But this is, let's say, manual, okay? This is not updated automatically. And this is just manual. What we can do is from the network context, let's say the previous device that we have seen, this one, we can see that it has a specific location. This information can be pulled from the medical protocol, okay? So in some cases, things like DICOM can include the actual device location. And we can also pull some of the information from the network itself. So we can see here information about the access point or switch where it is connected. And based on this, we can identify the relative location of the device. Hope this answers your question. Any other questions, things you'd like maybe to hear a little bit more about? Okay. Andrei, Alexander, anything from your side?
Well, so far so good. I think not sure if we answered the question about how is Russia defined, but like geolocation.
Yeah, it's a IPv4 geolocation. That's what I know. I can check it if there are any additional ways it is defined, but yeah, it's automatic. You don't need to do it manually. You just say Russia, and the system has this information on its own.
Great. What are the most, let's say, craziest use cases you have experienced maybe in working with this industry and with the solution, and maybe some findings, maybe some crazy scenarios?
Well, I have a hospital I'm working with right now. It's actually right now that they have a mobile CT machine that we have detected it having a ransomware and trying to scan both the local network and thousands of addresses in the internet to try to reach out to. We notified the customer about it immediately. They were like, oh, wow, that's cool. We're going to find it. And it's been 2 weeks ago. We are continuing to see this device popping up from time to time, like 2 days a week, approximately, still doing this behavior. And they are unable to find this device where it physically is. because it's mobile and it is being used. They know in which hospital it is, of course, but since it's connecting to the wireless network, they don't have a specific physical switch they can know every time where it is. They have the device name, but the device name is not shown physically on the device, so they don't know if this is it. And this is really crazy that they still, 2 weeks later, they still cannot find and mitigate this device in the physical world, although we provided them with all of the information, like you can see here on this level. And we also have the information about the access point, the wireless access point where it's connected. So it like closes it down a little bit. But since they don't have like a security personnel on site every time, so until he gets there, the device is disconnected, and and they cannot find it. So that's quite funny. I think that one of the most interesting things, and this is really in line with let's say what Forescout sees, that usually when we come to a hospital, when we come to a POV or deployed production environment, there is a specific expectation from the customer side. They have like a CMMS or CMDB with the device information. They know how many devices they have approximately. And we usually detect, just as Forescout does, about 30% more. And these are just the devices that are connected to the network. And this is really an eye-opener, because when we just run a POC and we start to show different devices to a customer that he didn't know that existed, or he thinks that he has, let's say 100 infusion pumps, and we show him that he has 200 of those, and 50 of them are like in very low use, and 100 of them are in constant use. So these insights both help to properly understand what's a baseline, to understand the type of securities they need to do, because if you don't know what you have, you can't really protect it. And if they apply some security to 100 of their infusion pumps, but they have 200 of them, well, that doesn't really help them to actually achieve this. So I think this is one of the nicest things that we see almost every time, just showing customer information about also like Windows XP machines, Windows 7 machines that he didn't know that he has, that are of course unpatched, and they're very easy point of access to the organization. Some other cool things we've seen is, and this is actually one of the compliance issues that CyberMDX can detect, and this is called misuse of medical devices. So we have seen like MRI machines being used to access Facebook and YouTube and just browse the internet, because the nurse was bored there and just started to do whatever she wants, like with a regular computer, not understanding the potential risk of infecting this device with a malware or ransomware, and the potential impact of this on the hospital. So although this is called a compliance issue and not a threat, this is like really high priority compliance issues that we see. This is also something very nice when we show this to customers, to CISO, and he's like, oh my God, I didn't know that they do this. And this actually triggers, even in POVs, it triggers policy changes within the organization to ensure that those things will not happen. And this is actually a preventative type of action that CyberMDX helps customers to achieve. I see a question from Anton about how we deal with IPv6. So I will check this, because I'm not familiar with specifically this part, but I will ask our team internally. I'll write the question down, and I'll check with them how it's been dealt with. Okay.
Maybe you can tell a little bit more how organizations usually are trying this solution. Like what should be done in preparation, how it's being installed, what's the timing?
Sure.
Or something on this.
Let me just find one slide. Just a moment. Okay, this is a good one. Share this one. Okay. Can you see the architecture?
Yes, thank you.
Great. So just a little bit about how actually CyberMDX works on-prem. So we have two components, two main components: a sensor, which is located on-prem, and a cloud core. It's of course single tenant core. No information is shared between the customers. The sensor is located usually close to the core switch, and it gets a span, passive traffic span to it, so no active actions happening towards, let's say, the medical devices. We're just assessing the traffic itself, and only network traffic metadata, such as source, destination, a protocol, amount of communication, seen asked, seen received, etc. And of course, the device information and usage of the device information has been sent. Of course, no personal data, no patient data, no doctor data, nothing like that is being analyzed or sent to the cloud. And the sensor is also responsible for the integrations with things like vulnerability scanners, firewalls, NACs, SIEM solutions, network management, etc. The idea is to have, let's say, two-way integrations. On one hand, if we look at vulnerability scanners, we would like to make sure that those will not be scanning medical devices. On the other hand, we would like to have a better information about the actual vulnerabilities. So if we've seen a Windows 7 device that we know that has a specific RDP vulnerability, and the vulnerability scanner that does an active scan of that device can confirm, let's say, that the port is closed or that the vulnerability is mitigated in some way, it will enrich information in CyberMDX. And CyberMDX will enrich information in the scanner to make sure it will not actively scan, let's say, ventilator machine that is critical for patient care. And if something will happen to it, the patient will die. So we want to make sure that this two-way integration is working, and it helps organizations to improve their security posture. To start, let's say, if you want to try the system, there are two main ways to do this. We can have a POC that is very easy, that takes just CMMS or CMDB information from your side, and we create just the core part. We upload this static information to it, and we show you the CMDX system, give you access to the system that has, let's say, the inventory information, the vulnerability information, the recall information. It will, of course, not have all the network traffic and details that we get from a full system, but it doesn't require anything from your side to actually get this system and to try to feel how it looks and works, but just to provide the information about the medical device inventory that you currently have. And the other option is to do a full POV where we deploy the sensor. It can be virtual machine or a physical sensor on site. We create a cloud core for it. You help, of course, with spanning the network traffic. And once it's done, after a couple of days, that everything is connected and the system has learned the information, we go together through the UI, give you access to it, share the insights and the information that we have. And of course, towards the end of the POV, which usually takes between 2 weeks and 1 month, we provide you with a presentation summary, with a report of the main findings, the recommendations. This is usually done on, let's say, part of the network, of course, and doesn't cover everything. This is the idea of POV. Any questions on this part? Andrea, anything else you think we should cover?
I don't know. Maybe some participants maybe have some specific questions. So please don't be shy. It's a great opportunity to actually get a little bit more insights about this technology. From my point of view, this should be in every hospital, in every medical institution, organization. And I hope that some people who are actually running hospitals and running health services would step in and, oh yeah, we have something.
I'm not sure what it means. Andrei, do you know?
Maybe Roland could tell a little bit more about Linux. Okay, open cloud operating system.
What do you mean compatible? We detect those operating systems in the network. The sensor itself runs on Ubuntu. So I'm not sure about the question itself about the compatibility.
If about the detection and let's say visibility providing, then definitely it gives you full overview about which version and what kind of operating system it is on any of the devices. There are many different types of active and passive methods. How Forescout and CyberMDX actually can do the detection and provide this visibility actually of everything in the network. Valerie, how many how to say protocol types are at the moment for each part, like IoT, OT, medical, Internet of Things devices? Like I understand that Forescout alone could detect something around 150 different kind of protocols with this DPI. How many actually different kind of protocols CyberMDX provided for Forescout platform?
That's a great question. I don't know. I can tell that CyberMDX itself is detecting around, working with around 100 protocols. But again, our focus is on the medical and IOMT ones. Of course, standard ones like DHCP, etc., are covered definitely by both systems. But again, the CyberMDX main focus is on the medical part, and this is where we complete this this offering with the whole Forescout Continuum platform.
We have something else. Okay.